In this episode, we look at threat paths that often begin outside the organization's direct systems, even though they can still create very real security damage inside the organization. Security is not limited to servers, laptops, and applications that a company owns outright. Modern work depends on suppliers, service providers, cloud platforms, contractors, visitors, connected devices, physical spaces, wireless signals, and small technologies that move data over short distances. Attackers know this, so they search for paths that may be less protected than the main network. A trusted vendor account, a managed service tool, a public software as a service platform, a universal serial bus device, an Internet of Things camera, an operational technology controller, a visitor badge, a Bluetooth connection, a radio frequency signal, or a near-field communication interaction can all become part of an attack path. The main idea is that the first step may happen somewhere the organization does not fully control. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at Cyber.Me in the Bare Metal Study Guide series. Supply chain threats involve the products, services, vendors, and relationships an organization depends on. A supply chain is not only boxes moving through warehouses. In cybersecurity, it includes software vendors, cloud services, hardware providers, logistics firms, consultants, contractors, support companies, and any outside party that helps the organization operate. An attacker may choose a supplier because the supplier has weaker defenses or because the supplier has access to many customers. If the attacker compromises the supplier, they may reach the real target through a trusted connection. This can be more efficient than attacking each customer directly. A software update, remote support account, shared file transfer process, or third-party integration can become the bridge. Supply chain risk is difficult because trust is necessary for business. The organization cannot do everything alone, but every trusted relationship creates a question. What access does this outside party have? And what happens if that trust is abused? Managed service providers, MSPs, are especially important in supply chain security because they often manage technology for many customers. An MSP may provide help desk support, device management, backup services, remote monitoring, security tools, cloud administration, or network maintenance. That means the MSP may hold privileged access into customer environments. From an attacker's viewpoint, compromising one provider can create access to many organizations. This does not mean managed service providers are unsafe by default. Many provide valuable expertise that customers could not easily build alone. The risk comes from concentration of access. If a remote management tool is compromised, a stolen technician account is misused, or provider security is weak, the damage can spread through trusted channels. Organizations need to understand what their providers can access, how that access is protected, how activity is logged, and how quickly access can be disabled during an incident. Logistics providers can also create cyber risk because they connect physical movement, inventory, scheduling, customer information, and operational systems. A logistics provider may handle shipping data, warehouse systems, delivery routes, supplier records, or tracking platforms. If attackers compromise that provider, they may disrupt deliveries, expose customer data, change shipping instructions, or learn how products and materials move. In some cases, the cyber and physical worlds meet closely. A changed delivery instruction might send equipment to the wrong place. A compromised tracking system might hide theft or delay detection. A fraudulent message that appears to come from a logistics partner might trick an employee into opening a file or changing payment details. Logistics risk shows that supply chain security is not only about software. It is also about the systems and relationships that keep goods, services, and operations moving in the real world. Software as a service, or SaaS, providers are another major part of the modern attack surface. SaaS means software delivered through a hosted service rather than installed and managed entirely by the customer. Email platforms, document sharing tools, customer relationship systems, finance applications, human resources tools, ticketing systems, and collaboration platforms are common examples. These services are useful because they are easy to reach and support remote work. But that same accessibility makes identity and configuration extremely important. If an attacker steals a user session, tricks someone into granting access, compromises an administrator account, or abuses an integration, the attacker may reach sensitive data without ever touching the traditional internal network. SaaS risk often depends on permissions, connected applications, sharing settings, and monitoring. The service may be secure in its design, but unsafe use or weak access control can still create exposure. Third-party integrations make SaaS environments even more connected. One application may connect to another so data can move, tasks can be automated, or users can work faster. That can be helpful, but every integration deserves attention because it may have permission to read, write, share, or change information. An attacker may not need a user password if they can abuse an application token or connected service with broad access. A small tool approved for convenience may quietly gain access to email, calendars, documents, or customer records. Over time, organizations can lose track of which applications are connected and what they are allowed to do. This is why application approval, permission review, and regular cleanup matter. The issue is not that integration is bad. The issue is that trust should be specific, limited, and reviewed. A connected application should have only the access it truly needs. Universal Serial Bus, or USB, devices are small, familiar, and risky when they are not controlled. A USB device may be a storage drive, keyboard, charger, network adapter, or specialized tool. Attackers may use malicious USB devices because people are curious, helpful, or unaware that a small device can act in unexpected ways. A device that looks like a storage drive might present itself as a keyboard and send commands very quickly. A drive might contain malicious files with tempting names. A cable or charger might be modified for data access. A device left in a parking lot, conference room, or lobby may be plugged in by someone who wants to identify the owner or see what is on it. The safest security culture treats unknown removable media with caution. Small physical objects can create large digital consequences when they connect directly to trusted systems. Human threat paths include contractors, visitors, temporary workers, vendors, and anyone who interacts with the organization without being a regular full-time employee. These people may need access to buildings, meetings, systems, documents, or staff. Most are legitimate, but their presence changes the security picture. A contractor may have limited access for a project, then retain access after the project ends. A visitor may enter a controlled area by following someone through a door. A vendor may receive sensitive information because employees assume the vendor has already been approved. Attackers can also impersonate people in these roles because they appear normal in many workplaces. A person carrying a toolbox, wearing a delivery uniform, or claiming to be there for maintenance may not attract attention. Human access should be managed through clear visitor procedures, badges, escorts, access expiration, and verification before sensitive information is shared. Internet of Things, or IoT, devices create risk because many everyday objects now connect to networks. Cameras, doorbells, printers, sensors, televisions, conference room systems, badge readers, environmental controls, and smart appliances may all communicate over the network. These devices are useful, but they are often overlooked compared with laptops and servers. Some have weak default settings, limited update support, poor logging, or little visibility in normal security tools. Attackers may target IoT devices to spy, create a foothold, join a botnet, disrupt operations, or move toward other systems. A camera on a guest network may seem unimportant until it provides a path to internal services or reveals physical security patterns. IoT risk grows when devices are installed quickly and then forgotten. Asset inventory, network separation, updates, strong credentials, and monitoring help keep connected devices from becoming unmanaged openings. Operational technology, or OT, refers to technology that monitors or controls physical processes. This can include industrial control systems, manufacturing equipment, building automation, energy systems, water systems, transportation controls, medical equipment, and other environments where digital commands affect the physical world. OT security is sensitive because the impact may involve safety, production, equipment damage, environmental effects, or public services. These systems may have long lifespans and may not be easy to patch or replace. Some were designed before modern cybersecurity threats were common. Availability and safety often matter more than rapid change, so security work must be careful and coordinated. An attack against OT may not look like stolen data. It may look like interrupted operations, incorrect readings, disabled alarms, changed settings, or equipment behaving unexpectedly. OT reminds you that cybersecurity can protect physical outcomes, not just information. Physical access is one of the oldest and most direct threat paths. If someone can reach a device, a wiring closet, a server room, a badge reader, a printer, a conference room system, or an unattended workstation, they may be able to cause cyber harm. Physical access can support device theft, cable connection, screen viewing, hardware tampering, badge misuse, or installation of rogue equipment. Tailgating happens when someone follows an authorized person into a restricted area without proper entry. Shoulder surfing happens when someone observes information such as passwords, badges, screens, or documents. Physical security also includes doors, locks, cameras, visitor logs, guards, clean desk habits, and secure disposal. Cybersecurity depends on physical security because hardware lives somewhere. A strong password does not help much if a stolen unlocked laptop contains active sessions and sensitive files. Bluetooth threats involve short-range wireless communication between devices. Bluetooth is used for headsets, keyboards, mice, phones, speakers, cars, wearables, and many other devices. The risk usually depends on pairing, device visibility, software weaknesses, and user behavior. An attacker nearby may try to connect to a device, exploit a vulnerable Bluetooth stack, impersonate a trusted device, or capture information from poorly protected connections. Most modern Bluetooth use is designed with security in mind, but problems appear when devices are outdated, left discoverable, paired carelessly, or used in sensitive areas without thought. You do not need to fear every wireless accessory, but you should understand that short range does not mean no risk. If a signal can cross a room, a hallway, or a nearby public space, someone else may be close enough to try something. Wireless convenience always needs some level of control. Radio frequency, or RF, threats cover a wider range of wireless communication. RF signals support Wi-Fi, radios, building systems, badges, sensors, industrial equipment, and many other technologies. Attackers may try to intercept signals, jam communication, replay captured transmissions, impersonate devices, or interfere with availability. The details depend heavily on the technology, frequency, protocol, and environment, but the basic security concern is straightforward. Data and commands traveling through the air can sometimes be observed, blocked, or manipulated if protections are weak. Wireless systems can also extend beyond walls, fences, and property lines, which changes the boundary of exposure. A network jack inside a locked office is physically constrained. A wireless signal may reach the parking lot. Strong encryption, authentication, monitoring, signal planning, and device management help reduce RF risk, but defenders must remember that the air itself can become part of the attack surface. Near-field communication, or NFC, is a short-range technology often used for tap-to-pay, badge access, device pairing, and quick data exchange. Because NFC works over a short distance, people sometimes assume it cannot be risky. Short range helps, but it does not remove all concern. Attackers may try to abuse lost cards, trick users into tapping a malicious tag, relay communication, or place unexpected NFC tags in physical spaces. A tag on a poster, desk, or public surface could lead a phone to a website or trigger an action depending on device settings and user approval. Badge systems that use contactless technology also need careful management because lost, cloned, or misused badges can create physical access risk. NFC security depends on distance, device behavior, user awareness, strong back-end controls, and the ability to quickly disable lost or suspicious credentials. These threat paths are powerful because they often begin outside the obvious center of the network. A vendor account may become the first step. A SaaS integration may expose data. A USB device may compromise a workstation. A contractor may retain access after a project ends. An IoT camera may provide a foothold. An OT system may affect physical operations. A visitor may reach an unattended device. A Bluetooth, RF, or NFC interaction may create a nearby wireless path. Attackers look for the path that works, not the path defenders expected. The right mindset is to map relationships and access. Who connects to the organization? What devices are present? What services hold data? What wireless technologies are active? What outside parties can act inside the environment? These questions reveal risk that a simple server list might miss. As you continue with Security Plus version 8 and SY0801, remember that modern threat vectors often start beyond the systems an organization directly owns. Supply chain providers, MSPs, logistics partners, SaaS platforms, USB devices, contractors, visitors, IoT, OT, physical access, Bluetooth, RF, and NFC all expand the attack surface. The answer is not to eliminate every connection, because modern organizations depend on connection. The answer is to understand trust, limit access, verify relationships, monitor activity, and reduce the damage one outside path can cause. Security becomes stronger when you look past the obvious firewall and ask how the organization really works. Attackers do not care whether a path is technical, physical, wireless, human, or third-party. They care whether it gets them closer to the target.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.